So we're trying to find moment using a moment distribution table, moment distribution method. And the first step to find moment is that we have to find fixed end moments for all the spans in the beam. Here we can see the three spans A, B, B, C, and C, D. So we find fixed end moment for our respective spans. For the first span AB, it would be, the formula would be minus WL square by 12. W is the load and L is the length. And we assume that all the spans are, ends of the all spans are fixed. And we get respective values. First one, we can see minus 6 kilonewton per meter. We can be minus because we're taking from A to B, which is in anti-clockwise direction. So it is negative. So from B to A, it would be positive as it is as it is in clockwise direction. Similarly for BC, the formula here changes because of the change in length. In previous AB, we could see that it was 6, which is constant, and here it is 3 and 2. Like, so the formula would be minus WAB square by L square. No, it would be like BC square. So here, if we consider from B to C, then we got minus 2.4 kilonewton per meter, and from C to B, it would be WA square B by L square. As it is in clockwise direction, we take it as positive. And for CD with point load 3 kilonewtons here, and formula would be minus WL by 8, same as AB. And then we draw the distribution factor table. Here we take the two joints. Here we know that there are two joints B and C, and each joint is two members BA, BC, and CB, CD respectively. We need to find relative stiffness. So relative stiffness for any fixed far end, it would be I by L. And for a simply supported, it would be 3 by 4 I by L. Here we can see that it's only fixed end and we don't have any simply supported beam here. Yeah, so for BA, it would be I by L. L length is 6, so it'll be I by 6. And for BC, 2I by 5 because they asked us to take I as 2I. So length is 5, so 2I by 5. And similarly for CB, it would be 2I by 5. And CD will be I by 5. And then we need to find the sum of relative stiffness for B separately and C separately. We got 17I by 30 and 30I by 5. Then we need to find the distribution factor. So we need to divide K by sigma K, which basically means BA divided by sum of sigma K and BC divided by sigma K. Like for example, I by 6 divided by 17I by 30, we get respective value. Then we need to draw the moment distribution table. And here we need to draw joint A, B, C, D respectively. Then we need to write down the distribution factor for each of them. As A, and we don't have distribution factor for A and D as they're not the joints. Like we don't have to find for them. And the fixed end moment values that we have found by assuming that all of them are fixed end. Then here we have to balance and balancing is basically here in B joint B, we can see that in member B and BC, we can see that fixed end moment, like fixed end moment of B and BC, summation of fixed end moment of B and BC multiplied by the respective distribution factor. For example, here 6 plus 2.4 into 0.294. And whatever value we get, Like if it is a positive value, we need to change the sign to negative. If it is a negative value, we have to change it to positive. So we have to make it to the opposite sign. And similarly for CB and CD. And we don't have to balance A and B. It would, it's already zero. It would be zero. And this would be, and then the next step is carry over. And carry over, so it would be carried over from BA to AB as it is in span. So it would be carried over to that, and AB to BA. But AB doesn't have any value, so it would be zero only, nil. And similarly from BC to CB and CB to BC. Again, you can see here the CD to DC and DC to CD. But so basically, it would be carried over to AB. BA would be carried over to AB, but it would have half the value. So half of BA would be carried over to AB. Similarly, BC, half of BC would be carried over to CB, and half of CB would be carried over to DC. Then we need to keep repeating the step until we are close to a zero value. Like we need to make sure that we get close to 0.00 or 0.0 value. Then we can stop. So it is then we have done the same thing for next two, three several times. Then we can observe in the last step that we get 0.0, 0.038. So it's very close to zero. Then at the end, final moments, to find the final moments, we need to add everything from fixed end. If from fixed end moment, from here, from the third step till the end, we need to add all of those and we need to find the value. So this would be the fixed end moment value. Then we have to draw, then we have to find, then we have to draw the bending moment diagram. Here for AB, BC, and CD, there's we have value, we have formulas for AB as it is a AB is a UDL. That's formula WL square by 8. So we got 9, and BC is a point load with different lengths. AB by L. We got 6. CD is a point load with the same length throughout the span. So WL by 4. We got 10, and we draw the bending moment diagram for this. Yes. That's it. Thank you.